Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
Third presentation, I'd like to hand it over to Chris Jordan, who's with the Advanced Systems Group at the Texas Advanced Computing Center. And he will be presenting about Cyberinfrastructure collaboration for distributed digital preservation.
Thank you. And just kind of by way of preface here, I realize a lot of the terms we use in talking about data, and particularly things like digital preservation, tend to be very slippery. So what I'll be talking about today in terms of digital preservation is not just the long-term storage of data, but really all of the services and resources that are required to handle data throughout the life cycle. And I think you've probably gotten a sense already just from the few presentations that you've seen today that even for a single domain or for a single data type, all of the processes and software that is required to handle this data is really enormously complex, and trying to build general cyber infrastructure that can support the needs of scientists with regard to digital data throughout the life cycle is a very challenging task. And so what I'm going to talk about is kind of building relationships and institutions and cyber infrastructure that can actually handle this diverse set of needs. Just a little bit about kind of what the National Science Foundation Supercomputer Centers are, since they'll be the subject of some of the projects I'll talk about later. The NSF centers have been around pretty much continuously since 1985. The few that I have listed here are really just kind of exemplars. There are many centers that provide high-performance computing resources for science and are funded by the National Science Foundation. The San Diego Supercomputer Center, the NCSA, and PSC are the three that have been around since 1985, and many others have been around in various forms for a while as well. And one of the functions of these centers has been to kind of promote various projects and be the hosts for development of projects, both in domain sciences and more generally providing cyber infrastructure. So the NPACI and TerraGrid projects are kind of national cyber infrastructure projects, NPACI being kind of a precursor to TerraGrid. GEON and SCEC are domain-specific geosciences and earthquake-centered projects, and Chronopoulos is a project I'll talk about in some more detail later that's specifically building cyber infrastructure for digital preservation. There's also been a tremendous amount of software development, some of which is widely used. The most famous example, of course, is Mosaic, which eventually became Netscape. And in many ways, it really is true that the internet and the web as we know it today was largely developed within NSF-funded centers, along with DOE-funded projects, DARPA. And there's also been a sense in which the centers, because they provide information technology resources, and because those resources are used by a wide array of sciences, they've been a site for multidisciplinary collaborations of many different kinds. And what I've done here is just kind of listed some of the other agencies that have been involved in projects at the centers, just to give you a sense of the scope. There's the Library of Congress, the National Archives, the Department of Energy and Defense, one that's not on here, the National Institutes of Health, and of course NASA. And just a little bit, in case anyone's not clear, cyber infrastructure is another one of those kind of slippery terms. The way I'll describe it here is as a collection of resources, which actually can include people, but typically is defined in terms of network, storage, high-performance computers, scientific instruments, and then kind of what we've described here as glue, the software and systems that integrate all of these pieces together. And one of the things that you've seen, particularly over the last several years, growing out of the Atkins Blue Ribbon Panel report that NSF commissioned, is a kind of shift in focus of supercomputer centers from being really oriented towards high-end computing and storage kinds of things to really being sites for advanced information technology development of all kinds. And you'll notice that the center that I'm from doesn't even have supercomputing in its name, even though we have the largest academic supercomputer in the world right now. There's a lot more that goes on at the supercomputer centers, and it's the expertise that really makes them valuable in this context. And I pulled this quote out of the NSF Cyberinfrastructure vision because it emphasizes this notion that what you're really enabling is distributed knowledge communities and collaboration and communication across distance, across disciplines, and even across cultures. That in many ways, in order to meet the challenges that face us both in domains and in computational science in general, you really do have to build organizations that transcend any of the kind of traditional academic or institutional boundaries. And just an overview of kind of what we believe the components that you need to do digital preservation and cyber infrastructure are, and there's kind of a stack here from the high-performance networks that allow connections between institutions up through the storage itself, the data grid technologies that link storage resources, the interfaces and services that allow you to access those resources, and then the technical and policy expertise that's required to manage them effectively. And I'll talk here about grid-based environments, and I want to make one point here because people talk about both grids and clouds, and I think it's important to recognize that both what's referred to as grid technology and what's referred to as cloud technology is effectively trying to accomplish the same thing. They're really talking about transparent access to widely distributed resources. The historical grid projects have kind of approached the problem from a different angle than the angle that's taken by cloud computing, and have chosen to solve different aspects of the problem, but ultimately the goals are really the same. So I tend to use the two kind of interchangeably. And in the context of digital preservation, obviously the replication and distribution of data is a critical aspect of what grid environments are doing. Obviously you're replicating data and distributing it to protect against, absolutely inevitable failures, especially when you're talking about the very long term. We know that everything from technology to people to institutions can fail in various ways, and you don't want the progress of science or the preservation of data to be affected by the failure of any component in the system. And it's important to note that this is kind of the way that libraries do preservation. There's an assumption that a book or a journal that's stored in a library will also be stored at many other libraries. And so if that item happens to be damaged or lost for any reason, it's extremely likely that there will be another copy at another location. And again, talking about grids, the supercomputing centers have by necessity long realized the value of networks to connect resources and distribute computation, the importance of both locally available and distributed data. And what I mean by that is that data needs to live close to the researcher in order for them to work on it, but it also needs to live close to the resources that they're going to use to analyze it or to perform other computations on it. But there's obviously really significant problems in doing that. You don't always have a high-speed network close to the researcher, close to the resources that they want to use. And of course, there's numerous problems related to having many different administrative domains and the level of control that those administrative domains want to exercise over their own policies. And there are many projects, including TerraGrid, which is the one that I work on, but also the Open Science Grid in the United States, and overseas there's DESA and EGEE. In Japan there's NAREGI, that have been dealing with these issues for a long time and have developed some expertise in what the problems are and some solutions for some of the issues. Just briefly, I'll give a couple of examples of data grid technologies because these are used in some of the projects I'll talk about later. The Storage Resource Broker and iRods are projects that were developed initially at the San Diego Supercomputer Center. And the idea here was to kind of put together in one package the various types of functionality that you would need for a data grid. Some important components of that are the association of metadata with data to form kind of compound objects, the ability to replicate data across resources, the notion that when you access data, you should not necessarily have to worry about the specific location of the data, and also that you shouldn't necessarily have to worry about authentication to data, to resources that may store the data in different administrative domains. You should be able to authenticate to the data management system itself and then retrieve the data without worrying about where it is or who's controlling it. So you have virtual namespaces, you have tools for verification of the data so that you know that what you put in is what you get out. This has been pretty widely used, both SRB and more recently iRods has been pretty widely used by libraries and different national and international organizations. So it should be pretty familiar to a lot of people in the digital preservation arena at least. And one thing about the iRod software is that a lot of the development of it was driven kind of specifically by some of the more complex policy and management needs of the users that SRB already had. There were some limitations of SRB in terms of policy and management that iRods was meant to address. And probably the most intensive set of policy and management needs are those of the National Archives Electronic Records Administration. So that was a big driver for why iRods is the way that it is. The flip side of that, of course, is that you have the ability to develop complex policies and complex management policies, but you also have to do the work to implement those policies. So it can be highly customized, but as with all customization, it takes time. A little bit about long-term archival storage. Sometimes people tend to talk as if it were incredibly difficult to actually preserve data for even decades at a time. So I like to point out that the three major supercomputing centers have been in operation since 1985. All of the data in their archives at the time of their inception in 1985 is still around today. They've been through several migrations across different software and hardware systems across different tape media, and they have managed to preserve that data. And in fact, a lot of the data that was put into the archives in 1985 was data that had been around since much, much longer. I think there are full copies of the original Berkeley source code, Berkeley Unix, and some of the SysV stuff, even from the 60s and 70s, that's still accessible in the archives today. And in order to do that, there is a significant amount of kind of format information, program code, translation of executables that has to happen in order to make that data readable. A lot of it does tend to be stored in ASCII text, which has been around forever as a standard. But that also goes to show that you can have formats that are relatively stable over very long periods of time, certainly very long periods of time thinking about the evolution of information technology. High-performance networks it's kind of hard to emphasize the importance of this in talking about distributed digital data. We always talk about the need for massive amounts of storage and the kind of data deluge, the massive amounts of data that are being generated. But in order to get that data from one place to another, you have to have some kind of network that can support that. A lot of the large new sensor projects that are talking about generating hundreds of terabytes or even petabytes of data every day, those sensors are located in very remote locations. And getting the data out of the sensors and into some kind of resource where you can perform analysis on it is a particular challenge. And again, this is an area where the supercomputer centers have been really instrumental. The National Lambda Rail and Internet 2, if you're not familiar with them, are two of the kind of big next generation high bandwidth academic network projects. And both of those are ones that the centers have been very closely involved in. And in fact, I believe the Global Network Operations Center for Internet 2 and Lambda Rail are here at Indiana University at the supercomputer center they have here. And they also continue to participate in the kind of local research and education networks that link up all of the various universities and in many cases libraries. So again, talking about how we manage and access data, it's really important to recognize that there isn't a single solution that solves all the problems. You need these kind of hybrid solutions. You need multiple layers to the solutions. There are different pieces of the stack that are going to be tuned for different aspects of the challenges involved. So in the case of the TerraGrid, you have the Globus toolkit is pretty widely used within the TerraGrid and in other grid projects. And it does include a lot of tools for managing data, particularly large data sets. It's not enough just to have a high-performance network. You have to have tools that enable movement of lots of data in a high-performance fashion. As much as we would like it to be, HTTP is not a high-performance data transfer mechanism. It's not sufficient for the needs of very large data sets. You also need tools like the reliable file transfer that manages failures and can restart transfers if they fail, and can allow you to transfer many, many files in a queued fashion without having to kind of constantly monitor the progress of each transfer. And then perhaps most importantly is the cross-realm authentication and security aspect of it. One of the first challenges that the grid people and Globus tried to address was the issue of how do you have one set of credentials that authenticates you to many different resources in many different administrative domains? How do you map between different security models and different authentication mechanisms? And they do have a way of doing that based on X509. And that's one of the things that I note a lot of the cloud models have not really done yet. If you have a set of credentials that work for, say, Amazon, that set of credentials is not likely to work for Microsoft Azure or any other mechanism. You're going to have one set of credentials for each cloud that you use. And that's a significant challenge to interoperability. And again, to make the point about multi-layered solutions, what TerraGrid has done is tried to build additional technologies and found that different components of the Globus software stack are useful in the context of more sophisticated technologies. One of the things we work on is wide area file systems. That is one file system that's actually available on multiple high-performance computing resources. That's something that scientists consistently tell us that they want. They want to be able to store their data on one file system and then work on it on the resource that's most appropriate without having to worry about moving it. And But in order to do that, we have to have the cross-realm authentication. And so what we've done is kind of built layers on top of these file systems that can perform mapping of identities across administrative domains. And similarly with iRODs, you're able to use the Globus security authentication layer to access the iROD service, and then you don't worry about what your identity might be on any of the underlying resources. So a little bit about libraries and why libraries might be interested in some of this stuff. Obviously, some libraries don't even have data centers, but for libraries that do have data centers, they tend to be older. They tend to be oriented not towards storage of the kinds of resources that libraries actually want to serve in a digital age. They tend to be oriented towards things like storing and searching the catalog of resources that they have rather than storing the resources themselves. But obviously the size of digital collections is increasing. The number of digital collections is increasing. A lot of journals, for example, it may make more sense now for a library to subscribe to those in purely digital form and store them in purely digital form, as opposed to actually receiving paper copies of 500 different periodicals. And of course, there's new ways of accessing data and searching for data. When they do studies on this kind of thing, they find that undergraduates and graduates nowadays, more than half the time when they're looking for a piece of information, they don't start with the library, they start with Google. And even if they end up at the library, they start with Google. And in fact, I think about half of the resources within a library that are located by college students are found through Google, not directly through the library's catalog. And then, of course, the campus research needs are evolving drastically as more and more science and research is done digitally as opposed to in physical form. And of course, all of these things have significant budgetary and physical requirements that have not traditionally been provided for in libraries' budgets and planning. So kind of a general model that I'll show some examples of in a minute for partnerships here. Libraries want to use the storage infrastructure and the tools that are in place at supercomputing centers. They want access to the technical expertise of a center because they don't want to have to develop or employ people that have all that expertise separately. Supercomputer centers need the kind of expertise in curation concerns and preservation concerns. How do you really manage large data sets? How do you make them accessible via different search mechanisms? How do you catalog the holdings that you have? And many centers do have very significant holdings after 20 plus years of supporting different kinds of science and preserving the results of that science. You get a pretty big body of data. And then, of course, they really want the long-term budgets that libraries have. Libraries have an institutional stability that's not typically seen in any kind of information technology organization. They're understood as an essential part of the academic enterprise in a way that information technology is not yet seen. And I also wanted to just point out that in addition to connections between libraries and supercomputer centers, I don't want to just limit the discussion there. There's also tremendous value to other kinds of collaboration with different private sector institutions. One of the things supercomputer centers have done very well is acted as a kind of laboratory for different information technology institutions, from Microsoft to IBM to Apple. They've been a place where these commercial providers can test out new technologies and develop those new technologies. And then, of course, you have things like Netscape that actually come out of the centers in the first place. So just quickly, I'll talk about a few of the projects that myself and my collaborators are involved in. The first is this partnership between TAC and the Texas Digital Library. Texas Digital Library is a network of 15 institutions of higher education in Texas who've kind of banded together to do collection and access to primarily electronic dissertations and theses to kind of create a unified institutional repository for all of these different schools that essentially have the same set of needs and feel that they can get an economy of scale by banding together. And of course, TAC has a pretty good-sized cyber infrastructure that really operates at the national scale. We support science both nationally primarily and internationally for the National Science Foundation. And then TDL has what I think of as an interface to Texas higher education. There's so many research needs out there and so much data being produced. It's very difficult to understand for a center that operates kind of independently from the university. It's very difficult to understand what all those needs are, who's doing what, and having a connection with a library, and especially with a statewide library program, is really important to us in understanding those needs. So what we're doing is kind of providing the storage and replication services, doing a lot of the management of the infrastructure for the Texas Digital Library, and then TDL is kind of working on the interface layer, on collecting the data in the first place, on providing the interfaces to the data. And the point is that we're both able to kind of focus on our core competencies, the things that we do well, and in combination, we kind of are able to produce something that's more than the sum of the parts. My colleague Robert McDonald here with Indiana University is involved in a project called HathiTrust, which includes all of the libraries of the Committee on Institutional Cooperation, and also the UC system has recently been added, the University of California system. And basically you're involving all of the libraries and information technology units in a broad collaboration to provide petascale storage and preservation for, I think initially the Google Books content, but the scope is potentially much wider than that. Is that correct? And currently they have two storage nodes, one in Ann Arbor at the University of Michigan and one here in Indianapolis. And they're kind of developing a wide area file system based on the Isilon storage, again, so you have something that looks like a unified infrastructure and provides a unified access point to distributed storage for numerous universities. And then San Diego Supercomputer Center has kind of a long history of collaboration with the UCSD Libraries. They've done some interesting things with actually bringing staff into both contexts, actually having staff that are employed both by the SDSC and by the UCSD Library, so that you have some movement of expertise kind of fluidly back and forth. And they've developed various service models based on specific projects. They've developed service level agreements that define the specific relationships between the libraries and the supercomputer centers, and provide a model for funding the kinds of services that are provided. And the goal of all this is obviously to reduce the cost for the library of storing and providing access to their digital collections as they increase their digital holdings. There was a pilot project that I and others at SDSC participated in with the Library of Congress, and basically we were looking at how would the Library of Congress manage the specifics and the trust aspects of storing data offsite at a center like SDSC, and so we took 6+ terabytes of data and moved it from the Library of Congress to SDSC and then provided different kinds of management services for them and then provided access to it. And that last slide is an example of someone else did that. That's why you shouldn't get too excited about new PowerPoint features. I really don't know why that was the way it was. The Chronopoulos project is an ongoing project that I think is pretty interesting, looking at, again, providing a persistent preservation infrastructure across multiple sites. In this case, SDSC, the National Center for Atmospheric Research, which is in Colorado, and the University of Maryland. And they basically set up kind of storage nodes at each location and are doing automatic collection, replication, and management across all of those sites. And right now they have several different collections that they're using. This is, again, kind of a demonstration project to show that we can ingest and manage data across a distributed infrastructure, even when it's very large amounts of data. And again, all of this is meant to be transparent to the collection's owners themselves. And then one last slide on this point. All of this stuff is kind of overlapping. It's all very, very complex, and it requires a range of expertise that is, I don't think, familiar either to librarians or to computational scientists or cyber infrastructure providers. The range of science that's actually being done is broadening. The level of science is getting more sophisticated. The amount of data it's creating is much, much larger. There are a next generation of national and international cyber infrastructure projects that are being developed now and will go into operation in the next couple of years that will have much more diverse sets of services, will serve much broader communities. And the next generation of libraries may not have bookshelves at all as access mechanisms move more and more towards electronic, and the need for printed materials decreases relative to the need for digital access to all kinds of information services. But I think this is great. I think the kinds of things that we're seeing are really fantastic across the spectrum of commercial and educational and institutional practice. There are fantastic new interfaces and new processes that are all coming down the pipeline now. So the point here is start talking to other people at other institutions, because we're going to need to collaborate across disciplines to meet some of these challenges. Yeah, I think at least for the time being, where most cloud storage models are, even if underneath the covers, the storage itself may be widely distributed, they still kind of exist as unitary entities. You have Amazon storage, and it has its own cost model, its own authentication model. I can certainly see treating that as essentially one storage resource among many. And again, in the context of data management, you may want to put some collections in a resource like that because of the requirements of it. You may have collections that don't need to be replicated into an online resource, for example. So that would make a lot of sense to me. Yes?
Do you come across those psychological reluctance for people to put their data into organizations like this? I find colleagues who felt that SRP, was something that was too remote to feel, and they actually ended up trying to replicate on the functionality locally because they trusted it more than this which I'm afraid they seem to think occasionally went wrong and they lost their data.
Right. Yeah, that's the issue of trust for repositories or projects like this is huge, and there are in fact institutional documents that attempt to lay out all of the components of an institution that is actually trustworthy. And one of the aspects of the Library of Congress project I referred to was, how do you establish trust? How do you prove that you can actually do this in a reliable fashion? But I find that it's generally the case that people believe they can do it themselves until something happens and they lose their data. And then they start thinking that they need a more robust mechanism. But it is the case that we also need to, over time, prove that we can do it reliably. Yeah?
One more question.
Has there been any progress made in this collaboration between libraries and the professional societies and the publishers, so that science is actually published in the library and then in the digital hospitals, and the libraries wouldn't have to pay so much of their budget to these proprietary journals sign on the copy?
I'd certainly like there to have been. Robert may have something more to say on this. I don't know of any specific progress that has been made on that front. I know it's something that a lot of people are trying to get done.
All right. Well, thanks very much, Chris. We appreciate it.